I am K. Aishwarya, Assistant Professor, Department of Physics, Madurai Sivahasi Nadar Bayanur Meenachi Women's College, Bhuvangi. 22BPH1C1 Mechanics and the Properties of Matter. I am going to discuss about the torsion pendulum with masses, without masses. Torsion pendulum. Torsion pendulum. A torsion pendulum is an oscillation for which the restoring force is torsion. Art is restoring, a force that acts to bring a body to its equilibrium position. So this is restoring force. This is fixed end. This is ionic wire. This is for disc. This is torsion pendulum. This is rotating in oscillation for 20 oscillation. In any 10 oscillation. This is rotation. Counting, this is 1, this is 2, this is 3. This is for count. So this is for torsion pendulum. A device consists of a disc or other body. Device consists. So disc or body. Now, which disc? Large moment of inertia mounted on one end of a torsionally flexible elastic rod wire whose other end is held fixed. If the disc is released. So twisting, twist released. It will undergo simple harmonic motion provided the torque in the rod is proportional to the angle of twist. Next, let C be the couples of the couple per unit twist. Let I be the moment of inertia of the disc about the axis of suspension. If theta twist of the wire at any instant, A angle of oscillation of the disc at as at that instant them. So twisting couples equal to C theta. Restoring couples equal to IA. At any instant, the above two are equal opposite. So, IA equal to minus C theta. A equal to minus C by I theta. Okay. So, A value. The angular oscillation directly proportional to angular displacement. The above equation is similar to the equation for harmonic motion. So A is equal to harmonic motion formula. A is equal to minus omega squared theta, where omega squared equal to C by I. The oscillation part of the torsional pendulum is simple harmonic. So angular velocity omega squared equal to C by I. So omega equal to root of C by I. Since the motion of the pendulum is period of torsion pendulum is T is equal to 2 by omega. So omega value, this value. This is for omega. So torsion pendulum using omega. This is for restoring force calculated in omega value. So using restoring force and twisting couple, A value, next angular velocity, next omega value, this for omega using omega calculation. So this is for calculated. T is equal to 2 by root of C by I. This for time period of torsion pendulum. Next, with symmetric masses, without symmetric masses. What is with symmetric masses? with symmetric masses. This is for torch elastic wire. This is for supporting fixed end. This is for disc. Okay, torsion pendulum with mass. What is with mass? With mass, this is center of disc. This for over end. This for 2.5 distance. First T naught. T naught. What is T naught? T naught is twisting and release. Twist and release is 20 oscillation. Counting. This for count 1 count, 2 count, 3 count, 4 count. This for rotation oscillation. So T naught. This is count. No masses. Next T1. This is for T1. This is for T1. This. So T1. This is for weight. Distance is 2.5. So this T1 equal to twisting oscillation. 20 oscillation counting in 20 oscillation twist list. So 20. This is for time is noted. Next. This is for D2 4.5 distance. So T2. Okay. This is oscillation. Length is 80. Same. T1, T1, T2. Length is same. Fixed. Next. With masses. Without masses. What is without masses? Length is decreases. This length is 80, 80, 80. 20 oscillation. Counting in 20 twist. Disc is twisted at the least. Is 20 oscillations. Counting. 8 length. Length is 8. Next 70 length. This is 70 length. Disc is fixed. Twist 20 oscillation noted. Time is noted. Next 60, 65, 50, 55. This is for without masses. Okay. Next, first with symmetric masses. A rigidity modulus of the wire can be determined using torsion pendulum by placing two equal masses on either side of the center of the disc. In this method, the mass of the disc is eliminated in the final calculation. T is equal to 2 by root of C by I by C. T squared equal to square root. So T squared equal to 4 by square divided by C dot I. Next, with disc along oscillation period is T naught. T naught, what is T naught? No masses with 20 oscillation is counted. So T naught equal to 4 by square divided by C dot I naught. I naught is moment of inertia is disc along. C is coupled per twist. So C, what is C is rigidity modulus is finding calculation by equal to n a power 4 divided by 2l. N is rigidity modulus of wire. A is mean radius of the wire. Length is suspension of wire. Okay. Next. With two equal masses kept at equal distance T1 and either side of the center of disc. So what is T1? Disc, center of mass. This for T1, 2 point distance. So kept equal distance. Either side in center of the disc. Okay, either side in center of the disc. This is center disc. This is center disc. This is mass. Okay. T1 square equal to 4 by square divided by C. This in this equations I naught equal to so 4 by square divided by C equal to I is moment of inertia, 2 length. plus 2 masses. So equation 2 ones. This values I naught plus 2L plus 2M square. This is for masses. So length wire, suspension wire. This is for masses distance. So d1 square, where I is the moment of inertia after each masses about its own vertical axis. Next, similarly, when the masses kept at distance d2, the period is t2. So t22 equal to 4 by squared divided by c into I naught plus 2L plus 2M square. This is for distance 2. Next distance, this center of this distance. Same each. So 4.5 distance. Okay. So equation 3. Equation 3 minus equation 2. So T22 minus T12 equal to 4 by square divided by C. This is common, so common. This is for I naught plus minus I naught. This cancel. 2L minus 2L. This is cancel. So 2M dt2. So C 2M dt2 minus d1 2. This is for C. C value equal to by n a power 4 divided by 2L. So 2L this is divided by n a power 4. So by 4 by square dot 2m into 2L d22 minus d12 divided by n a power 4. Okay, this equation. This is by cancel. 4 into 2 8, 8 into 2 16 by Lm d22 minus d12 divided by n a power 4. This value. This is for rigidity modulus of wire. So n rigidity modulus. So n equal to 16 by Lm d22 minus d12 divided by t22 minus t12. Okay, this value. Okay, sorry, a power 4. So a power 4. This value for n rigidity modulus. Next, I naught moment of inertia. So T naught squared equal to 4 by square divided by C naught I naught. This equation for 1. So equation 4, this T2 minus D12, this is T22 minus D12 equal to 4 by square divided by C into 2m D22 minus D12. So T1 square equal to 4 by square is equal to cancel. I naught equal to, so cancel those T naught square divided by T22 minus D1 square equal to I naught divided by 2m D22 minus D1 square. This is cancel. Okay, 4 by square, 5 by square cancel, C is cancel. I naught equal to 2m D22 minus D1 square. Okay. So this is for I naught. Okay, this I naught is moment of inertia. So 2m d naught square into t square divided by t naught t square equal to t1 square. So I naught equal to 2m t naught square divided by t22 minus t1 square divided by T22 minus D1 square. This is for I naught. Kilogram meter square. This is for moment of inertia. This is for moment of inertia. This is without masses, same rigidity modulus of symmetric wires. This ionic wire in ion wires is decreases. So decreases. This is decreases 80, 75, 70 decreases in oscillation in 20 oscillation counted in starter. This is for noted. This for time period. So value was time period calculation, I not calculation. This is for without masses. Thank you.